Hi everyone, welcome. In this series of videos we're going to look at the division of polynomials. Okay, in the last series we saw a little bit of the arithmetic that we can do with polynomials, so adding, subtracting and multiplying. Now we're going to look at division. Okay, this first video is going to hopefully give you a little bit of a deeper understanding of what is going on when we perform a division. And technically this video is not necessary for you to be able to actually do polynomial division. So you can technically skip it if you like, but I suggest you watch it just so you can get that deeper understanding of what's going on when we perform a division. Okay. Now, before we actually start looking at that, we've got some terminology that we have to set up for ourselves before we start doing the division, because I'll be referring to these words when we do our division for polynomials. So when you perform a division, you divide the dividend by the divisor. Okay, so I'm going to do some with numbers here, and we'll see what all of this stuff means in a second. So let's say I've got 16 objects. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, 16 objects. So this number would be 16. And I want to divide this group of 16 objects by, let's say, 3. Okay. Now, when you're in primary school and you were learning what division is, you probably heard the term shared between. Okay. So what we're going to do is we're going to share these 16 objects between 3 persons, okay, 3 people. And so the easiest way to do that is to just do, 3 sort of columns and just put these objects into the columns one at a time. Okay, and then once we run out of objects, you stop. So let's do that. So I'll do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and I've got one left over, which I can't really share between these 3 groups. Okay, if I can't sort of cut it into pieces, then it's sort of left on its own, so I'll leave that at the front here. Okay, so what we've done is we've divided 16 by 3. Okay, and you've seen that we end up with 3 groups of 5 objects. So the answer to 16 divided by 3 is going to be, well, 5 plus this stuff that's left over. Okay, now here's the thing. If we could split this leftover stuff equally and share it within these 3 groups, then we would get sort of a third of each of that piece. Okay, so the third might look like that for that group, that for that group, and then sort of like slicing it up like a pizza. Okay, so really the answer should be 5 and 1/3 of an object. Okay, so that's what this quotient here is referring to. The quotient is how many groups you've made, how many objects are in each group, and this part over here is sort of like the leftovers. Okay, I'll refer to it later as a decimal part. Okay, but what we've got basically, well, we had one object left over, so that was our remainder, but we still needed to share that one object between these 3 groups. So we have to divide that remaining object by 3. And so in total, what you get is 16 divided by 3 is 5 and 1/3. Okay, which is equal to 5.333 recurring. Okay, so that's what we're doing when we divide. Okay, this whole thing is to do with division of polynomials, so we need to understand what dividing means. And this is what happens when you get a remainder once you start trying to divide things. When you don't have remainder, things get a little bit simpler, but this is what happens when you get a remainder. Now what we can do is I can multiply both sides of this equal sign here by our divisor. I can multiply both sides by 3. All right, and so if I multiply the left-hand side by 3, I just end up with my dividend by itself. On the right-hand side, well, I have to multiply both of these terms by the divisor. So multiplying the quotient by the divisor just gives me divisor times quotient. And multiplying this remainder over divisor term by the divisor, well, that's just going to get rid of the divisor. And you end up with remainder. Okay? And so if I use the numbers that I've got here, basically what I end up getting is 16 equals 3 times 5, which is 15, plus 1 left over. Okay, and it all works out in the end. Okay, so these are just some terms that we're going to be using as we refer to the objects that we're manipulating in this video. But this is what's going on when you divide. Okay, let's look at that a little bit more in depth about what it means to divide things. So, why do polynomial division? What's the point? Why are we learning how to do this? Well, let's start off just looking at some numbers again. Okay, so let's say we want to do 273 divided by 13. You can do that on your calculator, you get 21, and you shouldn't get any remainders. Okay, it should divide evenly by 13. Now, if we end up with no remainder, okay, if it divides evenly, what can we say about these three numbers that we've got in our problem? Well, we can definitely say that if there's no remainder, that 13 is a factor of 273. That's what happens when you get no remainder. That's what a factor means. It means you multiply that number by another number, or in this case, when you multiply an integer by another integer, you get your original number back. So 13 is a factor of 273 because 13 times 21 is 273. What else can we say? Well, if we just reverse the problem and you say, well, what's 273 divided by 21? You'll get 13. Okay, because it's a factor pair. That's what happens when you interchange the factors in a division like that. Okay, so we can also say 21 is a factor of 273. Okay, so what does that mean? If 13 is a factor and 21 is a factor and they happen to be a factor pair, well, that just means when we multiply them together, you get 273. Okay, that's kind of obvious. Okay, I'm not really saying anything new here. I'm just sort of pointing things out to you. All right, and what we've actually done is we've factorized 273 into some factors. Okay, we've factorized 273 into 13 times 21. Okay, 13 itself is a prime number, so we can't actually divide that anymore. If we really wanted to, we can continue this factorization because we can factorize 21. And if you think of two prime numbers that can multiply to get 21, you'd end up getting a complete prime factorization of 13 times 7 times 3. Each of these are prime numbers. You can't divide them anymore. Okay, but at least we've factored it a little bit. We haven't fully factorized it, but we factorized it a little bit. Okay, that's really important. Okay, so when we divide by something and you work out the answer, you're essentially factorizing your original number. Okay, and that's why we're trying to do polynomial division. Okay, polynomial division is a really good way to try and factorize polynomials. Just in the same way that we've factorized 273 here. Okay, let's extend this out into polynomials now. So, let's say I've got these two polynomials. I'm dividing this long polynomial by x plus 2. Okay, forget about how we do that for now. We haven't learned how to do that yet. Just take it for granted that there is an answer, and we get an answer of x squared minus x minus 12, and there's no remainder. Okay, we'll see how to do that in the next video. So what does this tell us about these polynomials? Okay, just use the numbers that we used in the previous slide. Okay, it's exactly the same thing. All right, so if there's no remainder, well, what we've determined is that this x plus 2 is a factor of this original polynomial. Okay, that's what it means for there to be no remainder. We've also concluded that because the answer that we get is x squared minus x minus 12, and there is no remainder, that means x squared minus x minus 12 is also a factor. of our original polynomial. Okay, just like in the previous slide, we saw that 273 divided by 13 equals 21 with no remainder. That means 13 is a factor and this answer that we get is a factor. Okay, exactly the same thing is happening here. We can also say that if I multiply those two factors together, I'll end up with my original polynomial. And so, just like with our numbers in the previous slide, what we've actually done is we factorized this original polynomial into these two factors, x plus 2 and x squared minus x minus 12. Okay, so we factorized this. Okay, you haven't really learned how to factorize cubics, okay, polynomials of degree 3, but this polynomial division allows us to do that. Okay. Now, here's a question. What happens if there is a remainder? What can we say about the numbers and the polynomials that we're using if there are remainders? Well, let's just go back to numbers for a second. Okay, so instead of 273, add 1 to that, we'll go 274. So if we divide this 274 by 13, we get 21 with 1 left over that can't be shared between the groups of the 3 groups, the 13 groups. Okay, if we write this out, okay, go back to the first slide where we introduced the terms divisor, dividend, quotient, remainder. Okay, that just means that 274 is 13 times 21, which is 273, plus that 1 remainder, that 1 that's left over. Okay, if I now divide both sides, if I now divide both sides of this equation by 13, okay, I'll get my original division problem back because I'll be doing 274 divided by 13. That's here. And I now have to divide both of these terms by 13. So if I divide this term by 13, that just gets rid of the 13 here and I'm left with 21. If I divide this term by 13, I get 1/13. Okay, and this gives you the actual answer to our original division. 274 divided by 13 is 21 and 1/13. Or if you prefer in decimal form, it's 21.0769, where this 0.0769 stuff comes from here. Okay? So, because we have a remainder, that means that 13 is not an integer factor. Okay? It means we'll have 13 times some integer that'll get us very close to 274. In fact, it's going to be 13 times 21 to give us 273, but we'll have a little bit left over. And what's going on, just like with our original 16 divided by 3 problem, so what this division is telling us, we've got 13 groups, each with 21 objects in them, and then we have to share this one remaining object that's left over into these 13 groups. So we have to split that one remaining object into 13 parts to share it equally between all of them. Okay? And that's what that decimal part is referring to. Let's do the same thing with polynomials. Okay, you can end up with remainders when you do polynomials. It's a bit, what's the word? Intangible. Okay, it doesn't really have a concrete example or application that we can really use it for, apart from the fact that we can determine that if there is a remainder, it's not a factor. Let's have a look. So if I do this polynomial division, again, forget about how we actually do that. Just know that the answer that we get is x plus 9, and we have 29 remainder. Okay? So, again, just like in the previous slide, what we can do is we can write this out, and we can say that if I do my divisor times this quotient that we end up with, so x minus 2 times x plus 9, I'll get something that looks kind of close to this, but I'll have to add 29 to get this original polynomial back. Okay, so go back to the previous slide, go back in the video a little bit. All we're saying is this is like the 274, that's like the 13, that's like the 21, and that's like the 1. Okay, it's exactly the same thing, except instead of numbers, we're using polynomials. Right, again, what we can do is divide both sides by x minus 2 to get our original division problem back. So dividing all of this by x minus 2 gives you this term on the left here. And then on the right hand side, dividing this term by x minus 2 just gets rid of the x minus 2. We are left with x plus 9. And we have to add this extra, in quotation marks, decimal part, which is your remainder, your leftover pieces that can't be equally shared between, the groups, and divide that remainder by the original divisor, which in this case was x minus 2. Okay, so if you get a remainder when you have polynomials, your answer is actually going to look something like this. Okay, so it'll be this thing that you get after you divide, plus a little bit remainder dividing by your divisor. Okay, so this 29 over x minus 2, that you can consider the quote-unquote decimal part of your answer. Okay, it's the bit that you have to chop up into pieces to share it between the groups to actually find a final answer. Okay, so we'll stop there. This video probably is a bit heavy. It's very deep. It goes into concepts you probably haven't thought of too much before, or you probably have when you started learning this stuff, but over the years it sort of just slipped your mind and you took division for granted. But hopefully it gives you a bit of an insight as to what we're doing when we do divisions. Again, it's not technically necessary for you to know all about this stuff when we actually learn how to do division of polynomials, but hopefully it's given you a little bit of a deeper insight as to what's going on when we divide. Okay, so I'll stop there and I'll see you next time.